Hi, my name is Derry Discern. My project was lumbar interbody fusion or LIF cages in CAD modeling. Before I begin, I'd like to extend thanks to Dr. Anna Silva and Dr. Brian Kelly as they allowed me to be an important part of this project and and for allowing me to go into the BNI lab. And I'd also like to extend thanks to Dr. Brent Vernon and Dr. Madeline Andrews for giving me help and insight on this project. So lift cages are a medical device used in spinal surgeries that are meant to replace your intervertebral disc, which is the cushion between two adjacent vertebrae. These lift cages are placed in the disc to promote bone growth and fusion across adjacent vertebrae. There's several types of lift cages. There's interior lift cages, there's posterior lift cages, which are referred to as A-lifts and P-lifts. There are transformal lift cages, which are T-lifts, and lateral lift cages, which are L-lifts. The problem I sought to address was kind of creating a CAD library of various lift cages at various sizes. Developing a CAD library is a crucial step in integrating kind of 3D modeling to healthcare, as it would allow for further analysis of these lift cages. And then the secondary goal was kind of to create further analysis of the lift cages I was able to create and kind of create fibrous tissues using a real L3 to L5 lumbar spine segment from FEBio. This was done by kind of creating a design library as seen on the left, and then using that design library to create a series of these lift cages in SolidWorks, where I started with basic shapes of the cages and then started working on things like the ribs on them, any tabs, if there were any chamfers, fillet or fillets, and textures to kind of enhance the appearance and functionality. The result were these series of P-lifts, A-lifts, T-lifts, and L-lifts as seen on screen. And then the results for the secondary goal was kind of taking an L-lift and a T-lift and kind of adjusting them at 1 degree anterior, posterior, and flat and creating fibrous tissues at those different positions. This was done as fibrous tissue would be present under each lift cage as they were inserted into the spine, and it was for further simulation or accurate simulation of these lift cages at how they would react as the spine got different stress loads. The resulting CAD models make up a library that can be used in current and future finite element models of lumbar spines designed to examine the potential effects of various lift cages as well as their position and size. But to expand this project, I'd run the simulations mentioned in order to see how the lift cages hold up and would have created more fibrous tissues for a wider range of lift cages. However, time did not permit for that. But thank you.